Welcome to the Applied Science preview Q&A. So if you've got any questions, put them on the Q&A box. So you should be able to get onto that if you're on the Teams chat. Basically, all I want to do is run through the kind of course overview for Applied Science, introduce myself, and then mention why you might want to do this course. So first of all, just introducing me. My name is Adam. I've been at Bede for 5 or 6 years, so it's quite a while. And I've been teaching applied science since 2016, so I've got a bit of experience with that. I'm actually a local lad from Birmingham, so I grew up around here, and then I went off to Newcastle University to do my degree. So I've got a degree in chemistry and a master's in medicinal chemistry, and I did 3 years of quantum physics, so a lot of science. So basically, relatively qualified to teach an applied science course. I would say very qualified. I will say as well, normally if you do an applied science course at a college, you would have 3 separate teachers, but because I've got a specialism in all 3 sciences, I can actually cover the biology, the chemistry and the physics on my own, which means that you don't get split up between 3 classes, which is like a key selling point of doing applied science at Bede rather than somewhere else. That's it, that's my intro. I'm going to run through the basic course structure now. So I'll go through the first year because obviously most of you will be starting in first year if you do start at all. And in the first year, we've got a little bit of biology, a little bit of chemistry, and a little bit of physics. Probably can't see the stuff on the board, but I'm just going to quickly run through it anyway, even if you can't. So in our biology in first year, we cover some really relevant topics rather than a lot of plants, which is what biology tends to be. The applied science biology tends to have a lot more useful and modern applications. So we're looking at things like nerves, cell structures, so they are to do with humans. You're looking at how the brain controls the body and how the body is made up. We do mention plants a little bit just as a contrast to humans. We've also got microbiology and human tissues. So our microbiology, we're looking at things like viruses and bacteria and how they multiply, how they spread, how they can be so dangerous. And we also look at how you can identify them under a microscope. So we use live bacterial strains, we dye them, we look at them and we investigate them under a microscope. So our microbiology is really looking at modern things that are in the media right now as well, and how you can treat them and how you can identify what you've got. That's microbiology. And the last one on there is human tissues. So that's going to link to things like nervous tissue, which we've already mentioned, but also muscle tissue. So if any of you are interested in things like sport, then the muscle tissue and nervous tissue sections of this will go in really well with a sports qualification as well. That's the biology for the first year, basically. So it's not a huge number of topics, and that's because applied science is a mixture of all 3 sciences. So rather than doing biology for an entire year, it's only going to be a third of the year. So quickly moving on to our chemistry section. Got a big pop-up on the screen, just going to fix that. That recording. Our chemistry, we've got some just really straightforward basic chemistry. We've got structures, bonding, solutions and reactions. So you've already started some of that in your GCSE. Things like covalent bonds, metallic bonds, and how things react. We're just going to cover that again and then go into a little bit more detail, make it a bit more relevant, and then look at how those things are being used in modern society. So things like fuels and alternative fuels and how they exist and how they can be improved upon, but also how energy changes occur in the modern world. So are electric cars actually better for the environment than petrol cars? The answer to that at the moment is yes, but only if you drive them for about 25 years. So it's really looking at things on a much larger scale than you would normally think about them. And then the other one, we've got moles and trends and chemical properties. So that's to do with moles is all about how much of a reactant you would use. Trends is all about what do all of the elements have that makes them special. And you're looking at things on the periodic table of elements and learning all about that and why it's structured the way it is. And it gets to the point where once you've done that topic, you can look at a periodic table, pick any element, and tell me 5 or 6 things about it without ever having actually seen the thing itself. So it's quite a useful system that you learn for that. And the last one that's on there is chemical properties, and that's all about, why do things react? How do things react? Why do some things set on fire in a very ferocious way when they interact with each other, and why do some things not react? So that's your chemical properties, and that's your chemistry. So you can see a lot of it is linked to industry, and that's why it's applied chemistry. And the last one on there is physics, and physics tends to be a lot of people's least favourite subject. And I think the reason that is the case is that physics seems either pointless or abstract. And that's very much not the case with applied science. All of our physics content is linked to a specific purpose. So you're not just learning equations for the sake of learning equations. You're not learning outdated equations that have no real use in the modern world. We're looking at things like communication technologies and how they work. So everybody in the world has got a mobile phone, and hardly anybody knows how they actually work. So physics is largely communication based, which means that we learn about waves to start off with, what a wave is, how you can use a wave to send information, and then looking at really specific communication technologies like Bluetooth, infrared, Wi-Fi, radio waves, and what the advantages and disadvantages are in each case, and how you can actually calculate how far a signal can be sent based on one or two pieces of information. So I feel like the physics in applied science is much more relevant to a modern world than physics tends to be, and shouldn't really put people off if that's what the section was that you were scared about doing in applied science. So that's our 3 sciences covered. All of that will be assessed in one exam for each subject. Each of those exams is about 40 minutes long. I say about, it's exactly 40 minutes long, it's a government mandated time. So you've got 2 hours worth of exams total for your first year, 40 minutes for each subject, and they each count for a third of that unit. So equally weighted within that unit. But there is a secondary unit in applied science. Because it's applied science and it is a BTEC qualification, there is a coursework component. So our coursework component is 4 pieces of coursework in the first year. The first 3 are all about doing experiments, collecting results from them, and writing a lab report and producing a couple of graphs to go with it. If you can do that for all 3 of the first 3 pieces of coursework, then you're going to set yourself up really well with a nice high grade going into your exams at the end of the year, knowing that you already are working at a distinction level or a merit level. And it takes a bit of the stress off from doing the exam and thinking, oh, everything hangs on this one day. You've already done 50% of the work, because in the first year, the coursework is worth 50% of the total grade. The 4th coursework is kind of a self-growth and review of the year, and it helps you focus on things like transferable skills, things like communication and teamwork that you've developed and where you could develop them further in the year. So it's like an introspective essay rather than a lab report. So that's the overall structure of applied science. You've got 1 exam for each subject and 4 pieces of coursework. Actual experiments-wise, the experiments for the coursework are things to do with titrations. So it's about making up standard solutions, experimenting with them, observing colour changes. So this is pink at the moment, but it was colourless earlier. Why that happens, and making predictions about exactly how much volumes will be required to get that colour change. We also look at calorimetry and colorimetry, which are very similar in sound, very different in application. So we're looking at heat energy of things, which is kind of a physics topic, and colorimetry, which is about how pigments in plants create specific colours and how they respond to light through photosynthesis. So we actually take real plant specimens and extract chemicals from them and analyse them through chromatography. And that's it for our coursework. Next little bit, why would you want to do applied science here rather than somewhere else? And I think the main advantage I mentioned earlier is that you're only going to have the 1 teacher rather than 3. We've also got state-of-the-art labs that have been purposely built to have these sciences done in them. This lab is equipped with huge workspaces, really nice fume cupboards, all brand new equipment, and it's always getting replaced every year. It's really kept on top of, which can be very different to a secondary school environment that you might all be coming from. Also at Bede, with this being a coursework heavy subject, Bede has got a really good supply of computer rooms, and we've got plenty of time in our year to actually do some of that coursework during class time, and even outside of class. The facilities at Bede are really good for getting your coursework done. We've got loads of computer rooms, we've got LRC areas, libraries, and it's available all day, every day, and even after the school is closed on some nights. So there's plenty of support there in general. Next little bit I'm going to do is progression, and just say like what the students that do applied science go off and end up doing. And a lot of them are taking applied science alongside health and social care because the two really pair quite well. If you want to do something like midwifery or nursing, having a more scientific background might help you with your application. So loads of successful applicants this year going into nursing and midwifery and things like hygiene and care. So the practical skills that you learn in the applied science classroom and the techniques that you learn and the risk assessment and the health and safety, all that kind of stuff really does help with the health and social care section. We also have a lot of students go off to do things like crime scene investigation, forensics, and applied science at university as well. So very closely linked to the applied science subjects. And we have a lot going off to do things like biological sciences, where they want to go and study something that helps support the medical profession, like developing new techniques and new medicines and new drugs. We also had a few students doing sports science along with applied science, and having that higher scientific content than just the sports science. So you've got the pure biology, chemistry, physics in there as well, kind of helps strengthen their applications to university through sports science. And we actually have a few doing pure sciences at university. So they've taken one science at A level, picked up an applied science course as well, and they've gone on to do full science degrees at university. I will just quickly mention the second year because this is a 2-year course. And if you come through here and stay on the second year has got slightly more biology than the other 2 subjects. And that's because we focus on genetic engineering for our coursework module, and we do loads of advanced, relevant techniques. We learn about DNA amplification, DNA extraction, gene editing. So all things that are done in the modern world to try and treat things like cancer. We look at how they're done and we actually carry them out in a lab environment as well. And the exam for second year is all focused on how to create and carry out safe experiments to create reasonable and realistic results. So the exam in the second year is more focused on being an active scientist, doing things well, doing things safely, and proving that you are capable as a lab-worthy scientist, and the coursework is mainly genetics. So I think that's it for content-wise and what you can look forward to if you do applied science here, and a few reasons why you might want to do it. And that's it. So if you do have any questions, post them in the question box. That's it from me. Hopefully I'll see you soon.